Assalamualaikum and hi everyone. My name is Noraiman Sarah binti Zainuddin Faizal. So today my teammates and I we will discuss about Dichromate volcano and also about the volcano that we used to do during our primary school. And this is our video assignment for physical and inorganic chemistry. And before we proceed, let's know the other two of my teammates.
My name is Siti Aisyah binti Muhammad Isham, matrix number 207026.
Assalamualaikum and hi everyone. My name is Muhammad Fikri bin Muhammad, matrix number 208257.
Assalamualaikum and hi everyone. So today we will watch a video regarding the dichromate based volcano. So in this experiment we will build a model like a volcano using ammonium dichromate. So without wasting any time, let us watch the video.
Hello friends, how y'all doing? In today's video I'm gonna show you how to make volcano-like chemical reaction using ammonium dichromate. For this experiment we'll need ammonium dichromate and lighter. Okay, let's pour chemical on this tray. Just trying to make like a little hill like that. Now I'm gonna set this thing on fire and see what happens. Don't try this at home, guys. It didn't work first time, it was probably not enough fire. Well, let's do it again. Wow, that's pretty crazy.
Okay, now let me explain the video. So before that, a gentle reminder, please do not do this experiment at home because it is dangerous. If you want to do it, please take advice from the professional. Okay, so now let me analyze the video. Okay, first, you can see in that video, first thing first, the guy pour the ammonium dichromate in the shape of volcano. Okay, so then the reaction that occur to produce a model like a volcano is decomposition of ammonium dichromate. Okay, so what we need to do, first we need to heat the ammonium dichromate and then it will decompose into chromium oxide, nitrogen and also water. So when we heated the ammonium dichromate, it will produce orange spark. Okay, as we can see in the image, orange spark like a fire, and then it will also produce a green chromium oxide crystal. Okay, so in that image the green color crystal is actually the chromium oxide. Okay, so this model is look like a volcano. The orange spark is like a fire and then a green crystal is like the miniature of volcano. So that is what actually happening in the video. So we need to heated the ammonium dichromate to produce a dichromate based volcano, and then it will decompose and it will produce orange spark and green chromium oxide crystal. Okay, so that's all. Thank you.
Now, let's see together the observation in this experiment. First, after we ignite the flame on the ammonium dichromate, orange sparks is produced and the ammonium dichromate start to burn. Second, the color change Ammonium dichromate is in an orange color, but once it is started to react to the heat, the color changed to a dark green. Third, a volcano eruption. The dark green ashes continuously produce in a large volume until ammonium dichromate is completely reacted. Let's discuss what is happened during this experiment. Reaction involved is when the ammonium dichromate is heated and produce chromium trioxide in a solid form, nitrogen gas, and also produce a water vapor. Ammonium dichromate releases heat during this experiment and it is decomposed. The decomposition is strongly exothermic. Meanwhile, for the product that produced, first, the chromium trioxide is in a form of solid and the dark green ashes is produced. It is produced in a large volume due to gas embedded. Next, the nitrogen gas. We cannot see the nitrogen gas, but we can determine this by using the balance equation. Lastly, the water vapor. We can use a watch glass and place it above the Dichromate volcano. A water vapor will occur on the watch glass. Ammonium dichromate contains both reducing NH4 and oxidizing Cr2O7. During the decomposition of ammonium dichromate, chromium is reduced from +6 to +3 oxidation state and the dichromate ions oxidize ammonia to nitrogen gas and water. Now, we already know what is actually happening during the reaction. Let's learn another thing about this chemical. Ammonium dichromate will spread the flame rapidly. It is corrosive and also very toxic. It is also known as environmental hazard, which is dangerous to our environment, and also an oxidizer. While the chromium trioxide can cause irritating to skin and affect the respiratory tracts, it is carcinogenic and in amphoteric form. Therefore, goggles and gloves need to be worn during conducting this experiment. Nitrogen gas is colorless and odorless. We cannot see the nitrogen gas or even smell it. Lastly, the water vapor. It is formed due to redox reaction that occur during the experiment. We already know how to do and what is happened for Dichromate volcano. Actually, we can create an erupting volcano by using other basic items that we have in our house. So now, let's learn how to make our own volcano. It is easy peasy squeezy.
Our next mission is to discuss 5 other common product combinations found commonly in-house to create an erupting volcano. Although real volcanoes are a result of complex geological factors, this simple chemistry experiment produces an exciting visual reaction from the formation of carbon dioxide bubbles. Making your own homemade volcano is really simple and requires basic material that you can find easily at home. The materials you will need are red food coloring, dishwashing liquid, vinegar, baking soda, warm water, a spoon, a shallow tray, and a bottle. How to make an erupting volcano model? Step 1. Place the bottle in a shallow tray. You can decorate the volcano as desired if you want it to look like a real volcano. Next step is to put warm water into the volcano, add a few drops of food coloring, add a squirt of detergent. This helps the lava foam up and flow. Add a couple of spoonfuls of baking soda. When you are ready to start the eruption, pour vinegar into your volcano. Your volcano is about to explode. Watch the miniature volcano erupt. Next, let us discuss about the chemical reaction. What is happening? The reaction between vinegar and baking soda is a double displacement reaction. The baking soda, also known as sodium bicarbonate, is a base, while the vinegar, also known as acetic acid, is an acid. When vinegar and baking soda are mixed, hydrogen ions in the vinegar react with the sodium and bicarbonate ion in the baking soda. The result of this initial reaction is two new chemicals, carbonic acid and sodium acetate. The second reaction is a decomposition reaction. Carbonic acid is unstable and it instantly decomposes into carbon dioxide and water. Carbon dioxide is released, which creates the bubble, as the carbon dioxide gas is becoming trapped in the detergent. The pressure inside the volcano increases, causing what looks like an eruption. As these bubbles rise to escape the mixture, they make the entire solution erupt like a volcano, results in the flowing red lava. The leftover solution in the bottle is water. Food coloring is added to make the eruption extra colorful. Dish soap is added to capture more carbon dioxide for a foam-like effect. Liquid dish soap also makes the foam extra frothy and bubbly. It makes the reaction happen a little bit slower and last a little bit longer. Based on the experiment, bottle represents the volcano, foam while it is inside the bottle represents the magma, foam after it comes outside the bottle represents the lava. This is the balance equation for the reaction. The reaction between vinegar and baking soda is a double displacement reaction. The initial reaction is vinegar plus baking soda produce sodium acetate and carbonic acid. The second reaction is a decomposition reaction. The unstable carbonic acid instantly decomposes into carbon dioxide and water. Next is the physical changes observed. The solid baking soda was placed in liquid vinegar, producing carbon dioxide gas, which is evident because of the formation of bubbles in the forming mixture. Eventually, all of the solid dissolved and reacted, producing a new liquid solution. During the reaction, a solid and liquid have been chemically reacted to form a gas and a liquid. This experiment can also be used to explain foams as liquids or solids containing gas bubbles. That is all for our problem-based learning main group 4. Thank you.